So adding and subtracting square roots. We are going to treat this just like adding and subtracting everything that we've done in polynomials so far. And if you recall, anytime that we're dealing with adding and subtracting with polynomials, the keys that we're looking for deals with like terms. Now, we're going to use that concept very, very loosely because we're not really talking about like terms as they pertain to same variable, same exponent. But if the number under the radical is the same, then we have like terms. What am I talking about? If we take these numbers right here and we add or subtract them all together, what do we end up with? Again, the idea becomes this. Underneath the radical right here, I have the square root of 5. Okay? Underneath this radical right here, I have the square root of 5. These two guys are the same. They are, quote unquote, like terms. Underneath the radical right here, we also have the square root of 5. So really, all three of these guys have the same weight. In other words, I can add and subtract them all. Also, just like when we were adding and subtracting with polynomials, these things will not change. So because they're all the same, the square root of 5 is going to stay a part of the answer. Now, all we have to do is look at the beginning. Well, what's 5 plus 2? Hope you got a 7 on that one. 7 minus 4, we end up with 3. So in the end, that is as intense as that problem becomes. So we are looking for numbers under the radical. When they're the same, all we have to do is add and subtract the numbers that are in front of the radical. But obviously that's not always going to be the case. What happens when we run into a situation that looks a little bit more like this right here? Well, we can plainly see that these two numbers right here underneath the radicals are not the same. So of these two guys right here, do you think that we can reduce or simplify one of them? Well, the 3 right here is not going to change. We're going to leave that alone. However, the square root of 27 right here, I got a strong, sneaky suspicion that we can break that down. So let's take the number 27 and let's simplify that bad boy. Well, it's not an even number. 7 plus 2 is 9. So we know the number 27 is divisible by 3. So divided by 3. 27 divided by 3 is going to give me 9. 9 divided by 3 gives me 3. Do I have any pairs that are alike in this case? Well, we can take a look right here and see that we've got 2 of them that are the same. So a 3 is going to go outside of the radical. And then this last number 3 right here is all by himself, so he needs the protection of a little hut right there. Here's the other thing that's got to take place. Key moment right here in this problem. This 4 right here is still a part of the problem, or still a part of this particular value. So we got to bring that 4 over here, and we're actually going to multiply it times what we got when we broke down the radical of 27. So in this case right here, 4 times 3, because these numbers are outside the radical, becomes 12. Now we can take this number right here and plug it back into our original problem. So to restart it, I've got 5 radical 3 plus 12 radical 3. So now, do we have, quote unquote, like terms? You bet. Underneath the radical right here is a 3. Underneath the radical right here is a 3 as well. So all we have to do is add the numbers outside. So 5 plus 12 gets me 17. So it looked kind of funky in the beginning, but that's what you're looking for. If the numbers underneath the radicals are different, you need to attempt to simplify one of them, sometimes even simplify both of them. Then when you have numbers underneath the radical that are the same, again, quote unquote, like terms, then I could add and subtract the numbers in front and come up with the proper solution. So let's take a look at one more. And this one more we're going to have right here has an interesting finale. So the first one, 9 radical 2 plus 5 radical 3 minus 2 radical 18. So now we got 3 terms going on right here. It's just like the original problem that we had, or the very first problem that we did with this particular lesson. Let's take a look at the numbers underneath the radical. So right here I have the square root of 2. And here I have the square root of 3. Both of those guys obviously not the same. I can't add the two of them together the way that they currently stand. The last one here becomes the square root of 18. Of these three numbers right here, could I break down or simplify any of them? Again, the 2 is not going to change. The 3 is not going to change, but guess what? The 18 we can simplify. So come over here on the side, and let's break down the 18. Well, 18 divided by 2 becomes 9. 9 divided by 3 is 3. And so again, now I'm looking for numbers that are the same. Do I have any pairs? Right there become my 3's. So a 3 will be on the outside of the radical. The 2 over here is all by himself. So he needs the protection of the house, so to speak. And don't forget this 2 over here that we've got to bring over and multiply times the whole thing. So outside right here, I got 2 times 3, which becomes 6, and 6 radical 2. Now let's rewrite our problem and see if we've got anything that is the same. So 9 radical 2 plus 5 radical 3 minus 6 radical 2. And again, guys, this is just substituting. 2 radical 18 and 6 radical 2. If you plug both of those numbers into a calculator to the decimal, you would have exactly the same thing. Now we have a look here. I've got the square root of 2 and the square root of 2. Can we combine these two guys on the outside? You know it. So 9 minus 6 becomes what? Where I went to school, that was 3. And the 3 radical 2. Don't change that right there. Well, we've used these two numbers on the outside. Is there anything to add or subtract this guy to right here? Nope. So guess what? He gets a free pass all the way to the solution. We just rewrite it again. So if in the end we end up with two numbers right there that have different numbers underneath the radical, then we can't add or subtract them. So we just rewrite them as part of the solution.